Mm-hmm.
What is voltage for standard detection of 100 milliseconds? So if the voltage is less than 100 volts AC, then it responds within 100 milliseconds. But if it's greater than 100 milliseconds, greater than 100 volts AC, then it's at 30 milliseconds because it's easier to detect. How do we get to the schematic of the relay? How is it installed? You can view our manuals on our webpage, and that would give you the information on how this unit is connected. Is this ground monitor relay works for high voltage substations too? You can potentially use it on trailing cable as well, but we also do sell ground fault monitors by themselves without the ground check feature if needed. And that's where you can use the Sentry relay, which has a trip range between half an amp to 1200 amps and tripping within a second or less to meet those requirements of ground fault only. If ground fault ground check is needed at high voltage, then the GCHK 100 doesn't have voltage limitation. In addition to that, we also are compatible with 6 volt and 12 volt Zeners, as well as competitor-based CTs. And we have two different inputs we can take, either 1 amp or 5 amp, which gives us more flexibility. And the Zener is a very common ground check configuration for all providers, so it is very easily adaptable to our relay as well. The purpose of ground check is applied to indoor frame and electrical equipment as well by code or not. Mostly in the mining code, it stipulates that this ground check feature needs to be provided simply because your mobile equipment can be a few kilometers away from the main substation feeding it, and as a result, there's a need to monitor and ensure that the grounds are still intact at the mobile equipment to protect the workers from this frame potential that can occur. Is this relay able to be modeled in ETAP for arc flash calculations? I think that they do have some standard settings that can be configured for different ANSI codes, but I haven't checked. What would be the beneficial use of the relay such as GCHK 100 in a warehouse environment? If so, how would it be integrated? I think ground fault ground check relays are typically used in mining applications rather than warehouse environment. So unless your warehouse is utilizing very long cable connections, it's likely that you may want to opt for just ground fault only, in which case we do have I-Gard products and Sentry products which do just ground fault detection without the need for the ground check feature. Where does the output of the relay to be wired to shut down equipment or isolate electrical equipment? So the relay has dry contact outputs that can be wet with a voltage of 120 volts AC, and then they're normally open in normal operation and will close when a fault is detected to trip the breaker that is connected to those dry contacts. Can the relay communicate to other control systems such as DCS? Yes, it needs an I-Gard SIM, which is our communication module, I guess, and screen, and then it can use an RS-485 connection to the DCS. If your DCS is not accepting of a certain Modbus protocol or RS-485 connection, you may duplicate the contacts of the dry contacts and use them in a manner such that your DCS can read it. What is the max ampere rating in the main overcurrent protection device for grounding protection? If you're talking about a ground fault setting, usually for mines, they use a 20% pickup and are tripping within half a second or less. Thank you for good presentation. Thanks a lot. Does it apply to portable generators? It can possibly apply to portable generators that are in a mine. If they're being used as a means to power, it's possible. What is the difference between the standard GFCI receptacle and the GFCI receptacles used for equipment protection? The GFCI receptacle is tripping at 5 or 6 milliamps typically for people protection. The GFCI receptacles used for equipment protection may be having a higher setting of 30 milliamps for equipment protection or 20 milliamps, depending on which UL code requirement you're trying to suffice. I believe it's 943. What is the voltage used for the pilot wire test? Positive and negative pulses? Is it intrinsically safe? We have two different Zeners that we utilize, which is a 6-volt Zener and a 12-volt Zener. So it's been used for quite a long time, and that's pretty much the industry standard across us and other companies. So I would say that it's a tried method. Can this device be used for EHT circuits where we need 30 milliamp detection? I believe the relay goes down to 500 milliamps. I don't think it can get down to 30 milliamps, unfortunately. But we do have another relay that can do that, and that is the I-Gard 10C1. If we use a TXB sensor, we can get down to 10 milliamps using 3 turns through the CT, or we have a setting for 30 milliamps. What's the max adjustable setting? I think off the top of my head, it is 1200 amps. Do we need to use protection class CT for ground fault relay? Not necessarily. You can use a zero sequence current sensor. So at the moment we're using a zero sequence current sensor to capture the vectorial sum of the phase currents that are flowing through that CT window and then trying to pick up the fault current discrepancy. When is a neutral grounding resistor required? In most mining applications, they require impedance grounding. If you saw in the code requirements I was reading out, they say that the system shall be resistance grounded. If you have a delta system, a neutral should be established. Even in the CSA M421, it's pointing more towards resistance grounding, and very rarely you would see a solidly grounded system unless they're trying to satisfy single phase loads. For oil and gas as well, they also exclusively use resistance grounding. In 250.188a, what is meant by the neutral conductor needs to be grounded through impedance? This sounds like a resistance grounded system. That's basically the same as what they're stating for a resistance grounded system. So that's what that means based on the question that you asked. The additional feature of increased frame voltage is due to other ground faults, or are there more causes? A ground fault is an example of how the frame voltage can get elevated. One of the faults is on another ice system that's being isolated by a transformer, and that's how you get ground potential rise through the grounding points. That was one of the methods. The other method is through ground fault in the actual system without isolation, where it would elevate and cause a shock risk due to frame voltage.